Hey everyone, welcome back. I have a quick joke for you. Why do you suppose the student wore glasses only to math class? Are you ready? Because it improves division. Yay! And we're going to talk about division along with multiplication and how it applies to fractions. In fact, that is our objective for day 2, lesson 1.1, day 2. I will review how to apply the operations of multiplication and division to fractions. So I'm going to set my pen this morning. It's morning time for me. I'm going to choose this nice blue, and here we go. Okay. Multiplying fractions. This is a handy little thing to remember. Top times top, bottom times bottom. The basic technique is to multiply numerators, then multiply the denominators, keeping them both in their respective spaces, and then to use our strategies from yesterday to reduce. All right, so let's see how this plays out with an example. Let's look at example A. I have 3/8 times 4/9. My instructions say multiply top times top, so I get 3 times 4, then multiply bottom times bottom, so I get 8 times 9. Well, 3 times 4 is 12, 8 times 9 is 72. All right, now I ask myself, these are my strategies from yesterday, does 12 go evenly into 72? Yes, so I'm going to divide top and bottom by 12, and I get 1/6. Boom, done. The other way we could have done it is taken the 4, the 8, and the 9 and written them in terms of their prime factors. So my 3 stays exactly as it is, but my 4 is a composite number. So I'm going to write it as 2 times 2. 8 is a composite number, and if you write it in terms of its prime, it's 2 times 2 times 2. This is the equivalent of 8. 9 is 3 times 3, so here's my equivalent of 9. All right? Now I start applying, I look for pairs in the top and the bottom. So I have a 3 up at the top and a 3 down at the bottom, and I cancel those. Then I have a 2 on the top and a 2 on the bottom, and I cancel those, and a 2 on the top and a 2 on the bottom, and I cancel those. Now remember, these all become 1s, not 0s. Don't fall into that trap, okay? And then, so 1 times 1 times 1 is 1. And then on the bottom, I have 2 times 3 is 6. And I get the same answer both ways. Good? All right. Let's try this technique on these examples. Let's do number 1 together. I'm multiplying 4/12 times 3/20. My technique is top times top divided by bottom times bottom. All right, so I have 4 times 3, sorry about that, 4 times 3 over 12 times 20. Okay, 4 times 3 is 12. Well, look there, 12, I have one of those in my denominators, so instead of writing my 12 and my 20 out as products of prime, I'm going to use the fact that this is 12 and this is 12, and I'm going to cancel. So what's left in my numerator? Well, when I cancel, it becomes a 1. So it's 1/20, just like so. Now, on number 2, you'll notice that 16, it doesn't appear to have a denominator, but every integer is also a rational number that has a denominator of 1. All right? So anytime you have a whole number, whether it be a positive or a negative, you can put it over 1 and then apply this top times top divided by bottom times bottom. So I have 9 times 16 divided by 2 times 1. All right? Now, I'm going to take 16 and I'm going to rewrite it as 2 times 8. And I did that because now I have a 2 in my denominator that I can cancel it with. And I get 72 over 1, which is just 72. There's my final answer. Now why don't you hit pause on your player, do problem number 3 on your own, and then come back and see if you got it right. All right, welcome back. 6 times 5. I got to multiply my tops together. Then I have 20 times 42. Now there's lots of ways to do this. You can write all your composites as products of prime. Okay, so let's do that. 6 is 2 times 3 times 5. And then 20 is 2 times 2 times 5. And 42 is 2 times 3 times 7. All right? The 2's cancel. The 3's cancel. The 5's cancel. Now on the numerator, I just have a whole bunch of 1s, so I have 1. And in the denominator, I have 2 times 2 times 7. And that is 28. And there's my final answer, 1 over 28. You could have also noticed that you could write 20, like let your numbers, your reasonable numbers in a numerator or the smaller numbers help you decide how to factor 20 and 42. Because 20 is nothing more than 4 times 5. And 42 is 6 times 7. So then you could have canceled your 5's and your 6's and got to the same answer quicker. All right? All right, now when we have mixed numbers, we have one step that we have to do before the technique that we just learned. We're going to convert all of our mixed numbers. Remember what a mixed number is. It has a whole part and a fraction part. And we're going to convert it into an improper fraction. Okay? An improper fraction. To do that, we take our denominator times our whole number and then add the numerator. Denominator times whole number plus numerator. So I get 3 times 2 is 6 plus 1 is 7. That's where the 7 came from. 3 times 2 plus 1. All right? Now you try 5 and 1/4. Did you get 4 times 5 plus 1? Good. 4 times 5 is 20 plus 1 is 21 over 4. Notice that for the first fraction, because my denominator was thirds, my denominator is still thirds. For my second fraction, my denominator was fourth, so my denominator, my second fraction is, improper fraction, is 4. You got to keep those denominators as they are. Now, our rules for multiplying fractions say multiply the tops together. After that, we're going to multiply the bottoms together. Okay? Here we go. I have 7 times 21 and then 3 times 4. Okay? Now, I'm going to rewrite 21 as 3 times 7. So I get 7 times 3, and then I have 3 times 4. And notice that I have a 3 in here that can cancel. So I get 49 over 4. And if you want to write that as a mixed number, I'm going to go up here. You put 49 in the box, and you have 4 goes into 4 once, the remainder of 0, and bring down the 9, and 4 goes into 9 twice, with a remainder of 1. So this becomes 12 and 1/4, if you want to write it as a mixed number. Why don't you hit pause on your player and do example D, and then come back and see if you got it right. Welcome back. All right, I'm going to first convert. So I have 5 times 3 plus 4. 5 times 3 is 15, plus 4 is 19 over 5. Now I'm going to convert 6 1/2. 6 times 2 is 12, plus 1 is 13 over 2. If you look, you have all primes here. Okay, 19 is prime, 13 is prime, 5 is prime, 2 is prime. You see why it's good to know what your prime numbers are, because then you know you can't cancel anything, and all you can do is multiply everything straight across. So I have, my denominator is easy, that's 10. 5 times 2 is 10, and then 19 times 13, I'm going to go off to the side here and see if I can squeeze it in without causing my screen to go cattywampus. 9 times 3 is 27, carry the 2, that's a 57, and then a 9 and a 1, so that becomes, I don't want to get too close to my controls, 7, 4, 247 over 10, which is 24 7/10 as a mixed number. How'd that feel? Pretty good? Good. If at any time you don't get something right, play pause and rework your problem. All right, let's multiply these mixed numbers together. Go ahead, press pause, and then come back in. Okay, welcome back. I'm going to convert 2 3/8 to improper fraction. So I go 8 times 2 plus 3. 16 plus 3 is 19 over 8. Then I'm going to convert 3 1/5. So I have 5 times 3 is 15 plus 1 is 16 over 5. Okay. Now I see I have a 16 and an 8. And I know that 8 is a factor of 16. So I'm going to rewrite my top as 9 times 2 times 8. And then I have 8 times 5. And I'm going to cancel my 8s. 19 times 2 is 38 over 5, which if I divide that and make it a mixed number, equals 7 3/5. I'm very good with you leaving it like that, right? Number 2, convert. So I get 8 times 3 is 24, plus 3 is 27 over 8, times 5 times 1 is 5, plus 1 is 6. All right, I know 27 is 3 times 3 times 3, and 6 is 3 times 2, and 8 is 2 times 2 times 2, and then times 5. I don't have a lot to cancel here. I just have a 2 and a 2, and that's it. So I have 3 times 3, so I have 81 over 2 times 2 is 4, times 5 is 20, 81 over 20. Or this would be 4 1/20. Now, division. Okay, we're going to make division easy. by remembering a nice little way to change every division problem into a multiplication problem. I want you to keep in mind this little saying. I'm going to highlight it. Keep, change, flip. Okay? The basic technique of division by a fraction is to turn it into a multiplication problem and use the reciprocal of the second fraction. You're going to keep the first fraction as it is. You're going to change the division to multiplication, and you're going to flip or use the reciprocal of the second fraction. If you like poems, little rhymes to help you remember, if it's a fraction you're dividing by, turn it upside down and multiply. Okay? You have to remember that you flip the second fraction. That's how you make a reciprocal, by flipping the numerator and the denominator. Let's take a look at how this works with example A. I have 3/8 divided by 4/9. Okay? I have to, because this is a division problem, I have to apply the keep, change, flip. I'm going to keep my first fraction as it is. That's my keep. I'm going to change division into multiplication. Here's my change. And then I'm going to flip my second fraction. Keep, change, flip. Now I know how to multiply all day long. I can multiply fractions, right? So I have 3 times 9 over 8 times 4. Okay? And I get 27 over 51. And there we go. Now I know I can't reduce because what I have is the equivalent of a bunch of 3's in the numerator. And 3's don't go evenly into 8 or 4. So that's how come I knew I could just multiply without having to look for common factors. All right, why don't you press pause, and then try example B. Welcome back. I'm going to apply my keep, change, flip to divide 5/7 by 10/14. Keep is 5/7. Change is change division to multiplication. And flip is 14 over 10. When I do that, I'm going to rewrite 14 as 7 times 2. So I have 5 times 7 times 2. And then I'm going to rewrite 10 as 5 times 2. Now look what happens. Everything's going to cancel. My 5's cancel, my 7's cancel, and my 2's cancel. Now be careful. You might think this is 0. This is not 0. Remember, when you cancel, everything that turns to a 1. So this is 1 times 1 times 1 over 1 times 1 times 1. So that just equals 1. Dividing with mixed numbers. All right, we're going to just pop in that one extra step, and we're going to convert the improper fractions, convert the mixed numbers to improper fractions. So I have 3 times 1 plus 1 is 4/3. Divided by 2 times 6 is 12 plus 1 is 13/2. Now I'm going to apply the process of keep, change, flip. All right? So I keep 4/3, I change division to multiplication, and I flip my second fraction. And so I get 8 over 39. If you'd like to hit pause, you can do example D and then come back and see how I do it. Welcome back. All right, here we go. I'm going to convert. So I have 5 times 5 plus 4. 5 times 5 is 25 plus 4 is 29 over 5. 3 times 3 is 9 plus 1 is 10. So that's divided by 10/3. I'm going to keep my 29 over 5. I'm going to change my operation, and then I'm going to flip my second fraction. All right? 29 is prime, 3 is prime, and then I get, so I'm just going to multiply those together. 29 times 3, I'm going to go over here and do it, is 87. So I get 87 out of over 50. And if I divide that out, 50 is going to go into 87 one time, and I'm going to have 37 left over. Okay? Another way to check this is 1 times 50 is 50, plus 37 is 87. So you know you did it correctly. And here we are. Your homework that we're going to do in class tomorrow, if you'd like to take a peek at it, is 2, 4, 6, and then 33 through 54. So come prepared to work on problems, and because I'll be taking a grade at the end of class on your problems. So I'll see you tomorrow. Enjoy your evening. Thanks for listening. Bye now.